Today we're going to take algebraic expressions and we are going to look at how to label a bar model to represent that situation. But first we need to talk about some important vocabulary. These three words are words that you have heard me use, but yet we've not formally had a conversation about what they mean. When we talk about a variable, that's when we have a letter that's in a problem. A variable represents an unknown value. And we always use a letter. So this is represented by a letter. And that letter can be any amount of numbers. And you'll see that when we get into inequalities in a couple of weeks. But for now, what you need to understand is that a variable is an unknown value that's represented by a letter. A constant is a value that does not change. And a lot of times you'll see that represented by the letter K. But this is a problem, a number that is in a problem that stays the same every time. And then we have a coefficient. And a coefficient is the number that is being multiplied by a variable. That is being multiplied by a variable. And I'm going to give you a situation, an example. So if we had 6p, the 6 is the coefficient, the p is the variable. And this is like yesterday when we talked about how the number, the coefficient, and the variable, the letter, are always side by side. There's no sign in between them. This represents multiplication. So now let's look at a situation where you are going to sort the parts in these different expressions. I would number 1, 2, 3, 4, and 1, 2, 3, 4, so that you can sort these out. Pause this video, come back once you have them done. All right, so here are the answers. You should check and make sure that you have them correct. All right, so now let's look at our first example of a bar model. And you'll see down here we have a large bar, and that bar represents the whole. So this goes back to when you were in elementary school and you completed what they call the part-whole map. It may have looked something like this that had little circles, and you may have had a simple problem and you had to fill in your part-whole map. Like maybe you had 3 and you had 9, and you had to figure out what this other part was, which of course was 6. Well, this is kind of the step up from that, the upgrade from that little elementary skill that you used to do. Now, I always tell kids, just like with a part-whole map, we're gonna label the whole above the bar, and we're gonna label the parts below the bar. By keeping that in mind, by keeping in mind that you're thinking of parts and wholes, then that's going to help you to keep things organized and not forget anything. And by remembering that you're putting the wholes at the top and parts at the bottom, it's going to make things much easier for you. So think about an addition problem. This is just an expression, but if you had a full equation, you're taking two parts, you're combining them to create a whole. So to label the whole on this bar, we've got 7 and we have x that we are combining together. If we knew what x was, we could put one number here, but since we don't, we have to just write the whole expression, 7 plus x at the top. 7 is the first addend, so I'm going to come down to the bottom of my bar, and I'm going to actually cut my bar into parts. I'm going to start off with 7, so I'm going to make 7 parts that are about equal. They don't have to be exactly equal. You don't need to break out a ruler, but they should be about equal. What's left over, the x, doesn't matter. So then we label this here. This is our 7, and this is our x. So these are the two parts that we're putting together. When we put the 7 and the x together, we end up with 7 plus x. Now, subtraction is a little bit different. So if you think about the action in subtraction, and what's happening is you start with a whole, and you then are taking a part away and leaving a part. So we're working the opposite direction. But we're still, on our bar model, we're still going to label the whole at the top and the parts at the bottom. So when we think about the whole for subtraction, in this case we're starting with t. So this whole bar is worth t, whatever that is. But then we're taking away 2, and you see how that is the subtrahend. That's the second factor, the second number in our expression. So I'm going to put that on the right-hand side. My 2, I'm going to cut that 2 off. So this whole thing is t. This part is the 2 that I'm taking away. And this part that we're left with is whatever t minus 2 is. We have no idea what that value is. But our whole is definitely the t, because that's where we started. Multiplication. We've talked about how to read this. We would read this as 3 groups of y. Okay? So we know that with multiplication, we're taking apart the groups that have a certain amount in them, and we're putting them together to make the whole. So when we label the whole on the top for this bar, this is going to be 3y. 3y is our whole. Now, with multiplication, remember we always have 3 equal groups. So I'm going to divide my bar into 3 groups that are about equal. Doesn't have to be perfect. And then each bar is worth y, because those are the 3 parts that we're putting together that give us 3y. And then lastly, division. With division, what we're doing is we're taking a whole and we're separating it or breaking it down into equal parts. So our top, in this case, we have z divided by 3. So our whole is z. And we're dividing it into 3 equal parts. So I'm going to cut it into 3 parts. So our cut of our model looks just like the multiplication one. But my label is what's different. So this is whatever z divided by 3 is. Each of these gets labeled with z divided by 3. For example, if this was 15, each of these would be worth 5. But we don't know what it is, so we have to use our variable.